Hello, today's video is on the number e. Yes, we are talking about the number e, not the letter e. The number e is also called Euler's number. So even though it looks like Euler's, it is called Euler. So Euler's number is a special irrational number, and we use the letter e, and it is the sum from n equals 0 to infinity of 1 over n factorial. So what does that mean? That means we're going to have 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. And we're going to do this forever until essentially we get to infinity. Remember, there is no infinity. So what does this actually mean? Well, 0 factorial is 1, so this really means 1 over 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4, and that pattern is going to continue going on forever. If you notice what's in the denominator, each time there's another number that we're multiplying by. Well, if you watched the video yesterday on what is e and that explanation, what happens is that it takes the idea of doubling over time and kind of creates a curve that goes along with it. So this value eventually approaches 2.71828. This is, and that number goes on forever as well. This is an important number that will be used in quite a few different things in math and science, including cell multiplication, the exponential growth, a lot of times with banking, and then also with natural logarithms, which we'll be getting to a little bit later in this unit. So one of the first things we're going to look at is the laws of exponents using e. So every time we use it in this case, it's going to be a base. However, sometimes that number can be used in different locations as well. So our first example we're going to look at is what happens if we want to simplify 12e to the 8th over 10e to the 3rd. So even though e is the number 2.71812, we never want to substitute that value in. So what does this really mean? This means 12 times and then 8 e's on the top. 6, 7, 8. And then we have 10 and 3 e's on the bottom. Now, what the rules of exponents then say, if we don't go to actually just their simple memorization, is we can cancel out anything that's the same on the top and bottom. Now, when we look at 12 and 10, 2 can go into both of those. So we get 6 on the top and we get a 5 on the bottom. And then what do we have left? Well, we have e to the 5th on the top. So now let's use another example. We're going to do 3 times 2e to the 3x to the 3rd. So what does that mean? Well, that means we're going to have 3 in front times 2e to the 3x times 2e to the 3x times 2e to the 3x. So what's inside the parentheses, we are writing down 3 times because of that exponent. We can then take all of the numbers that are in front and multiply those together. So we get a 3, a 2, a 2, and a 2, which if you multiply that together, that gets you 24. And then we take our exponents and we add our exponents together. So that means we're going to have e to the 3x plus 3x plus 3x, because those are the exponents. So what does that mean? That means we get 24e raised to the, then 3x plus 3x plus 3x is going to be 9x. So 24e to the 9x. Now let's look at one more example. It will be e to the x times e to the 5th times e to the x plus 3. So if you notice with some of these, our exponents are getting more complicated. But what we need to remember here is that when we have separate bases, we always just add the exponents together. So this is going to combine to be 1e, but then it's going to be raised to the x plus 5 plus x plus 3. So what we are doing is we are taking each exponent and bringing it into the addition problem, the x, the 5, and then the x plus 3. From there we can combine like terms, and that's going to get us e raised to the, well, we have 2 x's, and then 5 and 3 gets us 8. So e to the 2x plus 8. Now, one of the things that you did on Monday, I believe, was graphing exponential equations. Well, that's all that e is. E is just an exponential equation. So let's take a look at what e to the x will look like. So we're going to make a table, our x and our y table. And what we have here is we are going to have -2, -1, 0, 1, and 2. So when we are graphing, we can go ahead and put in the number of 2.718 as the value when we're calculating this. So you want to make sure that you have a calculator handy, or you can always go to Desmos as well. That's a way to do it. So the first thing is we're going to have e to the 0. Well, just a reminder, anything raised to the 0 power is 1. So 0 is going to get us 1. Then we're going to have e to the first. Well, e to the first is going to be 2.718. Then e to the second. So then there is a button on the calculator that is an e, but if you don't have that, either go to Desmos or you can just approximate it right now as 2.718. And e to the second gets you 7.39 for that value. We're then going to have e to the -1. Well, that means 1 over e to the first. So that really gets us 1 divided by 2.71. And 1 divided by 2.71 is going to get us 0.368. Then we have e to the -2nd, which is 1 over e to the second, which will get us 1 over 7.39, and 1 divided by 7.39 is going to get us 0.135. So now we're going to go ahead and take a look at this graph. So I graphed it using Desmos. So the graph using Desmos is this graph right here. So this graph, which was probably not good to put in that location, so that graph, which is now gone, that graph shows that we are going to go through the point 0, 1, and then we are going to go to the right one and then up to 2.7, and then at 2 we're going to be up at 7.39, 1, 2, 3, 4, 5, 6, 7, and 8, and then going back the other way it's going to get smaller and smaller. So this pink graph is going to represent e to the x. Well, now what I want to look at is I want to look at what happens if we wanted to graph y equals 3 e to the x. So the easiest thing to do is to take the table that we already have, and when we were at -2, we were at 0.135. This is for e to the x. Then at -1, we were at 0.368. At 0, we were at 1. 1, we were at 2.71. And then 2, we were at 7.39. So now if we wanted 3 to the x, so let's take a look at what happens when we put in 3 to the x. So when we put in 3e to the x, what's going to happen is essentially just our y values are going to be multiplied by 3. So 3e to the x, I have no idea why this is causing so many issues. So let's try this one more time. So 3e to the x means that we are just going to take our y values and we can multiply them by 3. So that will get us 3 times 0.135 would get us 0.405. 3 times 0.368 is going to get us 1.104. 3 times 1 gets us 3. 3 times 2.71 gets us 8.13, and then 7.39 times 3 is going to get us 22.17. So what I'm going to do is I'm going to graph this on the same graph. So what I want you to recognize is we no longer need this middle value. So we're going to go to 0, 3, and then 1 and 8, and 2 and 22, that's going to be off the chart. Negative 1 will be at 1, and then negative 2 will be at 4.5. Well, what happens with the graph is that 3e to the x, that's going to go through the point 0, 3. So 3e to the x is going to go through the point 0, 3. This is really not working. Then, but e to the x went through the point 0, 1. So what happens is we need to remember that our graph goes through whatever that first value is. Now, in the top equation, it's really y equals 1 e to the x. Now, anytime the graph is going up, that means it is a growth equation. Now, let's look at one more equation. So let's see here. So due to some issues with the previous one, I'm going to go ahead and throw the graph on here. Well, I'll do it in a second. So what ends up happening here is we're going to use that same table, x and y. But in this case, we need to look at what's going on. So negative 2, negative 1, 0, 1, and 2. So our first one is e to the negative 0. Well, there's no such thing as negative 0, so it's just e to the 0, which is 1. We're then going to have e to the negative first power. Well, e to the negative 1 means that this is 1 over e to the first. And again, 1 over e to the first is going to be 0.367. Then we're going to have e to the negative second, and this is going to be 1 over e to the second, and that's going to get us 0.135. Then we're going to have, on the other side, e to the negative of negative 1. Well, when we have the two negatives, that makes this e to the positive 1, which is 2.71. And then e to the negative of negative 2 gets us e to the positive second, which is 7.83. So now we're going to graph this. So what happens when we graph this? Well, again, we really just need that bottom value, but we need all these in between to calculate it. So we're going to be at 0, 1. We're going to be at 1 and 0.367, 2 and 0.135. Negative 1 is going to get us at 2.71, and negative 2 is going to get us up to between 7 and 8. 1, 2, 3, 4, 5, 6, 7, and then 8. So it's going to be here. So what happens is this graph goes down. This becomes a decay problem. Now that is critical for you to remember. If e is to a negative x value, that means it is always going to be a decay situation, because e to the negative value means, or negative x equals 1 over e to the x. And since e is 2.7, when you get 1 over 2.7 something to some power, that number will be getting smaller over time.